All right, here's a discussion of the quiz that you all just took. I'm going to talk about every single problem in some detail, so skip through whatever problems you don't need to hear about. Very few of you had any trouble with problem number one, for instance, but here's some detailed work. The problems were all essentially the same between period 1 and period 3. The only difference really was the numbers from one problem to another. So Alice runs on the inside circle, and so she runs the circumference of the circle, which is 120 pi feet. Bob runs the circumference of the outer circle, 144 pi feet. There's the calculations there. Very little trouble with that. You can go look at my detailed work later if you really need to see it. Number 2 caught a few more people. Not a lot of people, but it caught more than 1 or 2, that's for sure. I'm asking for the circle's diameter, and here are the words full circle, which suggests the word circumference. So you're going to need the circumference formula. And most of the people who got this wrong did not write down the formula, as I've been urging you both in class and in my video. Start by writing down the formula. Okay, the 75 goes in for the circumference. You're making a circle with the rope. The rope is the circumference of the circle. It's not the diameter of the circle. So it goes in for C. Or in the case of period 3, it was an 80-foot rope, but it goes in for C. Okay, I wanted an answer to the nearest tenth. Everybody gave me an answer to the nearest tenth. That's good. Number 3. Find the length of an arc. You need an arc length formula. And here is the one that I'm choosing to use because it is already solved for arc length rather than the other one. Okay, with a radius of 1, therefore the diameter is 2, and so the circumference is 2 pi. So plug that in for the C. This puzzled me here, why so many people did not use the 120 degrees for the theta. And truly, it wasn't a lot of people, but again, there was more than 1 or 2 people who subtracted that 120 from 360 to get 240 degrees, which you would use if we were trying to find the length of the arc from C around the long way to D. And maybe that's what some people thought, is that they had to go around in that direction. There's no particular direction, clockwise or counterclockwise, that you have to go to trace an arc from its starting point to its ending point. You can go in either direction, but when you only get a 2-letter arc name, that must be what we call a minor arc. You must travel the shortest possible path from C to D. And clearly that would be the path that I've highlighted there in red. And so you would use the 120 degree angle. Now I asked for an exact answer here. And most people gave me an exact answer. There were only a few people who gave me an answer that was really close, but it was not exact. 123/60 reduces to 1/3 times 2 is 2/3. So here are 3 all valid ways of writing the exact answer, but there were a couple of people who just wrote something like 0.6 pi without the repeating sign, and then that's not exact. Okay, third period didn't really have that issue so much because it turned out to be 3/4, which you can write simply as 0.75 pi, which is totally acceptable. Okay. Number 4 gave an awful lot of people trouble. And to be honest, this didn't shock me. But if you read the problem, we're taking a 75-foot rope and we're tying it to point P and we're wrapping it around the circle. So here's an illustration. Okay, that red arc is the rope. Now, I don't know how far it goes around the circle. I don't know if the way I've drawn it, it looks like it's going less than halfway around. I don't know if it goes less than halfway around. Maybe it goes more than halfway around. But I don't have to know if it goes less than halfway or more than halfway, if it goes less than 1/4 of the way around or more than I don't need to know that in order for the picture to help me solve the problem. Okay, but the 75-foot measure there is an arc length, right? It's being wrapped around the circle, but only part of the way, and we don't know how much of the way, but it's just part of the circle's circumference. So it's going to go in for arc length in this arc length formula. And I'm choosing this version of the formula just because it's going to be a little less algebra for me to solve for the theta. All I'm going to have to do is multiply both sides by 360. But the 75-foot rope length, whatever the rope length is, in period 3, I think it was an 80-foot rope, that goes in for the arc length. And then this theta here is what I'm looking for, right? How many degrees around? Again, the way I've drawn it looks like it's might be less than 180 degrees, but who knows? It might actually be more than 180 degrees around the circle. So I've got to find the circle's circumference. Well, if the radius is 15, the diameter is 30, and the circumference is 30 pi, since I'm asking for an answer to the nearest whole degree, I'm not asking for an exact answer, we can turn that 30 pi into a decimal number right now. So 94.2 approximately is the circumference. Put that in for C. So right here now is the formula with all the values substituted in. Multiply both sides by 360 and simplify the left-hand side with a calculator. You get 286 degrees. In third period, with an 80-foot rope, turned out to be, I think, about 306 degrees. I don't think anyone really would have had trouble with the algebra. Everybody who set this up right, did the algebra right, pretty much got the right answer. The thing that really troubled me most, well, I guess there were two things that troubled me. One is that people just did not write down a formula involving arc length, but I suppose that might have been because they just didn't realize that 75 feet is, in fact, an arc length in this problem. So I could forgive you for that. But what troubled me in many cases was people who wrote down C is equal to pi times diameter or 2 times radius. I saw a lot of people writing down the formula 2 pi r instead of pi times diameter. That's fine. That's an acceptable formula for circumference. And writing down 30 pi and getting 94.2, now that's the circumference of the circle. Circumference is a length. The length unit given here is feet. And so this 94.2 is a length in feet. It's the circumference. But then people wrote in the answer blank 94.2 degrees, which really makes no sense at all. But I guess they were just, reaching for some answer. They did some calculation. They got a result. They thought, well, I'm not really sure what's going on in this problem, so I'm just going to write this down. Oh, and since he asked me nearest whole degree, I'll just write degrees instead of feet. But you probably knew that there was something wrong with that. Okay. If you didn't, that's what really troubles me. If you didn't know when you wrote down 94.2 degrees that something had to be wrong with that, that's a little worrisome. Okay. Number 5, almost nobody got the numbers wrong, but a lot of people did not write square centimeters for the area. Listen, folks, area is always square units of some kind. And I don't care if you write it centimeters to the second power, or if you write the word square, or even the abbreviation SQ, but you cannot just write centimeters. That's plain wrong. Okay. Almost nobody had any trouble at all finding the total area for number 6, and people did it using a variety of different strategies. Most people did an addition strategy. Few people used subtraction. No matter how they did it, pretty much everybody got that right. You can look at my detailed work later if you want. Let's talk about number 7, because there were a bunch of people who had trouble with this. And number 7, the given information was 14,400 square inches. You know that my advice to you has been to take the square root of that given value and see if you get a nice whole number. Well, in this case, you do, 120. So if we invent a rectangle, which in this case would be a square, that is 120 inches by 120 inches, that would be a rectangle whose area is 14,400 square inches. But how long is 120 inches? Well, you know that there are 12 inches in a foot. So divide 120 by 12 and you'll get 10 feet by 10 feet. And now among all of these choices, a bedroom floor is definitely going to be the closest to 10 feet by 10 feet. Basketball courts are way bigger than that. Football field, gargantuan. A single bed mattress, like a mattress in a bed, big enough for only one person, okay, which is probably the type of bed many of you sleep in. Maybe not. I'm sure many of you do, not all of you, but a single bed mattress. It's only a little bit taller than you. You're 5 or 6 feet. Your mattress maybe is 6.5 or 7 feet tall, and it's only a few, like maybe 3 feet wide. Okay. So 10 by 10 is considerably bigger than that. So the bedroom floor is the best choice. For period 3, the given area was not 14,400 square inches, it was 100 square yards. Well, you probably don't even need to reach for a calculator to turn that into a rectangle that is 10 yards by 10 yards. But again, you're probably not as familiar with yardages or yard lengths as you are with feet lengths. But I know you know there are 3 feet in a yard. So if you have a square that is 10 yards on each side, it's going to be 30 feet on each side. Now, in period 3, you did not have the choice of a bedroom floor, but you did have the choice of a classroom floor, which is considerably bigger than pretty much anybody's bedroom, but not nearly the size of a basketball court. 30 feet by 30 feet, that's pretty darn close. That's really, really close, actually, to the size of our classroom floors. So that would be the best choice there. Okay. Let's talk about number 7 and 8, which a lot of people got wrong. Number 7, area is 1/2 times base times height. That's the formula for triangle, 1/2. Some people just plain old forgot the 1/2. You didn't get any partial credit for this problem. It was 1 point. You either got it right or you got it wrong. If you use the wrong formula, you got it wrong. The base is 3, as I've drawn here. The height must be at a right angle to the 3, and the height has to extend all the way up to be level with point D. The height does not stop here like some people drew it in. It has to go all the way as high as like the top of the triangle. Okay, and so that's 5 units long. The parallelogram, the area formula is base times height. And again, you can use any side of the parallelogram to be the base. I have always advocated use either a horizontal or a vertical side for the base. And so here's a vertical side, and it is 3 units long. Some people extended that base all the way down here to sort of be even with that end of that base and called the base 5. No, the base is always exactly whatever the length of a side of the figure is. You never have to extend the base or draw it through anything or anything like that. The base here is 3. The height must be at a right angle to that base, and it must go all the way to the other base, which is 8. Pretty much nobody messed up on the height being 8, but a bunch of people used 5 for the base. What troubles me a little bit about people who got either one or both of these wrong is that there were lots of problems like these for you to practice in homework assignment 12.1 and 12.2. There were a bunch of these, not just like 1 or 2, a bunch. You might want to go back, any of you who missed either one of these, I mean, you decide. You might want to go back and pull out, like reprint or just bring up on your computer screen again, a clean copy of homework assignment 12.1 or 12.2, and just redo those problems where I'm asking you to find the areas of those figures on the grid. Okay? Now, your choice, whether you feel like you need that practice or not. Number 9, it's parallelogram. And the area of a parallelogram is the base times the height. The height is not 10. Most of you did realize that, but some of you didn't. The height really needs to be drawn in here And then you need to use your 45, 45, 90 right triangle knowledge to solve for the height. So here's the height. It's 10 divided by radical 2. Now, I asked for an answer to the nearest tenth. Let's talk about that in a couple of ways. Since I did that, one option for you was to immediately reach for a calculator and punch in 10 divided by radical 2. And you would have gotten 7.071. And then you could have multiplied your base 50 times your height 7.071 and gotten your area that way. You did not have to go through the simplifying of 10 divided by radical 2 to get this exact radical answer. But it's okay if you did, as long as you then multiplied your base times that height and got 250 times the square root of 2 and then turned that into a nearest decimal answer. I was really surprised at how many people wrote 250 square root of 2 in the answer blank when this phrase is staring you right in the face as you're writing down 250 radical 2. Nearest tenth. I want a decimal answer to the nearest tenth. Now, I know, because some people were chatting with me during the quiz, that there are a couple of people out there who literally did not know how to do that. I think most of you really should have, but I kind of don't know. I think some of you maybe did not realize that this number, 250 radical 2, means 250 times the square root of 2. And so you can just pick up your calculator and punch in 250 times the square root of 2, and it'll give you that decimal result. Okay. I hope that doesn't trip anybody up next time, because that's really a pretty easy thing to be able to do. In number 10, once again, the formula is 1/2 times base times height. And a lot of people did know the correct formula and tried to use the correct formula, but made a careless mistake. You got to use your 30, 60, 90 right triangle knowledge this time to find the height of the triangle, which turned out to be 7 radical 3 for period 1. For period 2, it was 8 radical 3. Now look, the area formula is 1/2 times base times height. The base of this triangle is this entire 14, right? I mean, that's 7 and that's 7. So this 7 is the base of that 30, 60, 90 triangle. But we're trying to find the area of this original triangle, whose base is 14. So 1/2 is part of the formula. The base is 14. The height is 7 radical 3. And that all simplifies to 49 radical 3. In period 3, the base of the triangle was 16, not 8. There were people who were doing this 1/2 times 8 times 8 radical 3 and coming up with an answer of 32 radical 3. And that was, I think, just carelessness. I think in most cases, people who made that mistake are probably going, oh, okay. Whereas some of these other mistakes, like maybe some people not knowing that 250 square root of 2 literally means 250 times this, maybe that was something that some of you truly did not know. Okay. So that's it. That's all I want to say about that. Some of you might need to put in a little more practice on some of the problems like these, numbers 7 and 8. Truly a problem like number 4, I don't have a stack of problems for you to practice like that. I knew it was going to be a little bit of a challenge. I knew that some people were going to have difficulty recognizing that this 75-foot measure becomes an arc length in this problem. When the next quiz comes around and the test comes around on this entire unit, expect that there's going to be a problem or two where you have to do a little interpretation or a little figuring out of what is this thing, or what does this represent in this problem. That's part of being in an advanced level math class, right? So I don't have lots of problems for you to practice. If I gave you 10 problems like number 4 to practice, or 5 problems like number 4 to practice, then it would be a super easy problem. And then I'd have to invent another kind of problem to challenge you a little bit. Okay. Be careful, pay attention to the exact versus the nearest tenth kind of thing. And again, for a problem like number 2, write down the formula and plug stuff in to the proper place. My guess is that most of you who made the kind of mistake I described on number 2 are also going, oh, but I think some of you were genuinely confused about what the 75-foot represented in this problem. I don't really think this should have been as challenging as number 4. I mean, a full circle that you can make with a rope. The problem is telling you you're making a circle with the rope. I was surprised as many people used that length for the diameter as it did. Next time, I'm sure you wouldn't. Okay, that's it.